Assalamu alaikum wa rahmatullah. Hello everyone. In this video I will be doing another question related to question 19 from the coverage of grade 12. Again, I have just selected the question 1 and the question 2 from my file, which has more questions. So no one knows what will be in the exam. So again, please practice all of the questions provided in the revision files. So in this question we have a region enclosed by two functions and two lines, the y-axis and the line x equals 2. Now let's label, before we start doing the part A, let's label the functions on the graph. The upper one looks like a parabola, so it will be the parabola, right? The quadratic. So this is h of x. The upper one is h of x, and the lower one will be g of x. You can sketch also these two functions in your graphing calculator if you don't know how to distinguish between them. So graph them in your graphing calculator, you will get to know which one is h and which curve belongs to g. Now for part A, it says find the area of region R. So for part A, we need to find the area, which is given by the definite integral from 0 to 2 of the upper function, which is h of x. It's 6 minus 2 bracket x minus 1 whole squared minus, open another bracket for the lower one, which is g of x. So it's minus 2 plus 3 cos of pi over 2x. Close the bracket dx. Okay, so let's evaluate this integral. Well, we have x minus 1 all squared and we have cos of pi over 2x. For both of them, we may use the u substitution method, okay? However, we can just do it directly. I mean, we can, if we are good enough, we can use the u substitution mentally. So it will result in what? In this. So the integral from 0 to 2. Should we rearrange it first? Okay. Let's do that. Yeah, 0 to 2. We've got this 6 minus 2. It will be 8, right? Not the highlighter. It will be 8. Okay? 8 minus 2 bracket x minus 1 all squared and minus plus 3, it will be minus 3 cos of pi over 2x dx. Now we can integrate. That is going to be 8x minus 2. Now if we assume that x minus 1 is u, we will have u squared, integrate u to the power of 3 over 3, يعني x minus 1, which is already u, mentally, x minus 1 to the power of 3 divided by 3. So I'm going to put the 3 down here, okay? If you are not feeling comfortable with this, you can just do it using u substitution. Minus 3, and then the integral of cos is sine. So let's write sine of pi over 2x, and then you will divide by pi over 2 or multiply by 2 over pi, نفس الشيء. So this is 2 over pi, okay? This is all evaluated from 0 to 2. Again, you can use u substitution for the other one also. Cos of pi over 2x. Assume that u or w or whatever equals to pi over 2x, and then you can evaluate. Okay, so let's plug in the 2. We have 8 times 2 minus 2 over 3, and then 2 minus 1 to the power of 3 minus 3 times 2 will be 6. Let me write 6 better. 3 times 2 is 6. 6, no, not this one. 6 over pi sine of pi over 2 times 2 minus we have to plug in the 0 as well. So let's do it here. 8 times 0 is 0 minus 2 over 3 bracket 0 minus 1 cubed, and then minus 0, because sine of pi over 2 times 0 is 0. Sine of 0 is 0. So if you just evaluate this, you will end up having, let me check the answer. So this is going to be 44 over 3. 44 over 3. This is part A. Okay, so for the second part, it says region R is the base of a solid. Okay, so this is a slicing method for the solid at which x, the cross section perpendicular to the x-axis, so the cross section is perpendicular to the x-axis, has an area of 1 over x plus 3. So here the area is given, which makes it much easier for us, because the volume, because the question says find the volume of the solid. Okay, so for part B, the volume is given by the integral from a to b of a of x dx. And when I say a of x, I am referring to the area of the cross section, which is already given. So this is equivalent to the definite integral from 0 to 2, because it's perpendicular to the to the x-axis, of 1 over x plus 3 dx. And this is equal to what? What is the integral of 1 over x plus 3? It's ln of the denominator x plus 3. And this is evaluated from 0 to 2. And this is equivalent to ln of 2 plus 3 is 5 minus ln of 0 plus 3 is 3. That would be the volume, ln of 5 minus ln of 3. So part B was easy. Now let's look at part C. It says write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 6. So let's first erase h of x from here. And let's put it here. This is h of x here. Now, the axis of rotation is y equals 6. It's a horizontal line, y equals 6. If you count 1, 2, 3, 4, 5, 6, this is going to be the axis of rotation. So this is y equals 6. Now, when this region is rotated around this axis of rotation, again we will be having two radii, inner radius and outer radius. So the inner radius will be this much. Okay, so this is r small, and this one will be the bigger radius. Okay, so here we can say that the smaller radius or the small radius is the difference between h of x and the line y equals 6. So we can say it's 6 minus h of x. This is the inner radius or the smaller radius. It's only the difference between the axis y equals 6 and h of x. And the bigger radius will be the distance between, or the distance from 6, which is the axis rotation, to the g of x. So 6 minus g of x. So for part C, so what we are going to do in part C, the volume is equal to pi. As long as something is rotated, immediately there is pi, okay? Pi times the integral from 0 to 2. From 0 to 2, r capital squared, which is 6 minus g of x squared minus the inner radius, which is 6 minus h of x all squared dx. You can leave it this way, you can get the full credit here, and you can replace h and g with their expression. It's totally up to you. So 6 minus g of x all squared minus 6 minus h of x all squared. If you flip them, it doesn't matter, okay? Yani if you write g of x minus 6 all squared minus h of x minus x all squared, it will be the same. So this is all for question 19. 2, yani question 2 from the file of question 19. Hopefully everything is clear. Good luck.